using slopes and intercepts. Alright, so we have some new vocabulary. And the first one, well, the first two are going to be what's called an intercept. So we have our x-intercept and our y-intercept. So our x-intercept is the place on a coordinate plane where our line, so if this is my coordinate plane, and I do my line in red, where my line crosses the x-axis. Okay, so in this case that would be right here. Okay, and the important thing about that point is that it always has a y value of 0. Okay, anywhere on the x-axis has a y value of 0. And this makes it very easy to figure out in certain cases. And it also makes it really nice to graph, because if I know my x-intercept is a value, it's really easy to find. I just go to that value on my x-axis. Same with the y-intercept, okay, except now it's the point on the y-axis. Okay, so again, the y-intercept always has an x value of 0. Okay, so if I have those 2 points, which are pretty easy to find, pretty easy to graph, all I need are 2 points to graph my linear equation. Right? 2 points, put a ruler over them or draw a straight line between them, and that's going to be your graph. Okay, and as always, it goes on forever. Okay, slope-intercept form is a way of expressing a linear equation that gives us some additional information. Okay, it gives us the slope and the intercept, which is why it's named slope-intercept form. Okay, the form is here. It is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so this might look like y equals 2x plus 3, and you can remember from systems of equations or even just our multi-step equations, this is a pretty common form that we're used to, and having this y isolated and alone over here is what helps us with solving our systems of equations as well. Okay, so it's a really powerful form. It saves us a lot of time, and there's a lot that we can tell from it just by looking at it. All right, the last vocabulary is standard form, and this is another form for linear equations, and this has the form ax plus by equals c, and that's where a, b, and c are constants, so those are just numbers, right? So we could have 3x plus 2y equals 18. All right, that is another form for my linear equations. It's a little less powerful than slope-intercept form. There's not as much we can tell just from looking at it, but it does have some really good uses. And the most common one is finding our x and our y intercepts. Okay, so it's very easy to graph from our intercepts, and it's easy to find our intercepts from standard form. And that's what we're going to be doing in our first concept today. So we are finding our x and y intercepts in order to graph linear equations. Okay, and as I said, we need 2 points on our line to be able to graph our equation, and intercepts are the easiest to use. Right here I'm given the x-intercept is 5. So on my x-axis I count 1, 2, 3, 4, 5. Put my point. My y-intercept is -3, so I count down 1, 2, 3. And then I'm just going to draw a line. Go with red again. Draw a line to connect the two. And extend it out. And there's my linear equation. Okay, line goes all the way through. Pretty simple. Okay, pretty straightforward. All right, but that was a case where we were given the intercepts. Most of the time we're going to have to find the intercepts. Okay, so we're going to use standard form, and what we're going to do is we're going to use the fact that for my y-intercept, my x is 0, and for my x-intercept, my y is 0, to make it easy and straightforward to find those values. Okay, so if I put in 0 for y, 2 times 0, right? 2 times 0 is always going to be 0. Doesn't matter what this number is, it's always going to eliminate this value. And I'm going to be left with just my 3 times x equals 12. And that's something I can solve, right? Divide by 3, divide by 3, x equals 4. Okay? And that's my x-intercept, because that's the value of x where y is 0. Where y is 0, the value of x is 1, 2, 3, 4. Okay? Now same thing, I go back and I do it for x value is 0 for my y. So I've got 3 times 0. Again, that's going to be 0, so I don't have to worry about that. I'm going to be left with 2y equals 12. Divide by 2, divide by 2, y equals 6. Plot my point, 1, 2, 3, 4, 5, 6 on my y-axis, and then, once again, connect the 2 with a line, something like that. Extend it both ways, and there we go. Okay, so that's how to find our intercepts. Let's go ahead and do another example. Okay. So basically what you're doing, what this comes down to, is you are ignoring one of your terms, right? So if I'm finding my x-intercept, I'm going to ignore my y, okay, because I'm making that 0. I'm making all of this term kind of go away. So I'm going to have 4x equals negative 40. Okay, and I'm just going to divide by whatever number I have next to x, divide by that, and I'd have x equals negative 10. Okay, and then I'm going to do the same thing for y. Remember, that sign does need to be included. Okay, so I have negative 5y equals negative 40. Divide by negative 5, divide by negative 5, and y is equal to negative 40 divided by negative 5, or a positive 8. Okay, and now I've got those two. I can get my, let's see, this is 10. I can get my two intercepts. My y equals negative 10. Oops, sorry. My x equals negative 10. X equals negative 10, and my y equals positive 8. All right, draw my line. And we are done. And there we go. We've got our graph based on our equation using our two intercepts.